Hey everybody, let's talk about the International System of Units, or the SI system for short. So units are really important because the unit is the part of the measurement that tells us what the heck we're measuring, right? If I ask you to go out and run 5 tonight for homework, if you decide to run 5 feet, that's a pretty darn easy assignment. If you decide to run 5 miles, things are getting a little bit tougher, right? So if you don't have a unit on your number, it's pretty much useless in science. So we're always going to make sure we keep that unit. Now, SI units are very similar to something called the metric system, which you've probably heard of. So the metric system is the preferred unit in science. We are going to use the word metric and SI pretty much interchangeably. There's one notable difference that we'll see here in a second, and that actually comes into play whenever you come to this table, table B. So we have 7 SI units. These are things that you're probably familiar with, right? The quantity that they're measuring, if you want to measure how heavy something is, aka how much mass it has, then you're going to use something called a kilogram. And you'll notice that this actually has a prefix on it. So the prefix kilo is what makes this a little bit different from the metric system. The base unit for SI for mass happens to be a kilogram, not a gram, which is a little bit strange, but it's probably because kilograms are a little bit more recognizable for us. They're a little bit more tangible than a gram. But that's really the big difference between SI and metric. So we'll use SI and metric almost interchangeably, with the exception of kilogram. Kilogram is indeed the base unit for SI, but everything else is pretty much the same. So for length, we have something called a meter. For time, we have something called a second. For amount, we have something called a mole that we'll spend quite a bit of time on down the road. For temperature, we use a scale called Kelvin. Kelvin is the scale that includes absolute zero at 0. So right at 0 Kelvin, that's where molecular motion ceases to exist. If we want to figure out how much electricity is going through something, you've probably heard of the ampere or amps. And then luminous intensity is essentially how bright a light is, and we use something called candela. And you'll notice that all of those actually have an abbreviation that goes along with them that's very similar to the actual name of the unit itself. So kilogram becomes kg. Meter becomes M, and you'll notice that most of these are lowercase. And the beauty of this system is that on our next video, we'll learn that we can put different prefixes in front of these to basically scale them up by a certain number. But we'll get to that in a little bit. For now, let's play a little bit more with these units. So it turns out that you can make different units by having different combinations of those 7 base units we saw above. So for instance, what if you wanted to have 2 lengths in one, basically length and width? Length times width we know is area. If you have a length in meters and a width in meters, then your units become meters squared, meters times meters. If you add a third dimension height, you get meters cubed. We could take a mass over one of your volumes and have kilograms per meters cubed. So that is a way that SI units really work well. Another little key difference here between these 7 kind of base SI units and what we'll actually use in the metric system is in the metric system we have some more common units. So the SI system is not always the most common of units. For instance, density in the SI system, as we just said, is kilogram per meters cubed. But more often, we will simply use something like grams per milliliter, right? So it's still a mass over a volume, but grams per milliliter is a little bit more common for what we'll see. So let's do this. Let's have you try stating the physical quantity. And remember, physical quantity is defined right in this column up here. Physical quantity that would be expressed in each of the following measurements. So if we used a metric ruler, what are we measuring? Well, we are measuring length. And we could do that in something like meters or kilometers, kilometers for short. If we had 10.0 milliliters, we are measuring a volume. How would we do it? We'd probably use a graduated cylinder. If we had a thermometer, what are we doing? Well, we are measuring temperature. If we had a length of 75.4 seconds, a length of what? Well, that's a length of time. And we referenced this thing before. If we had a graduated cylinder, this one's already made it, through high school, maybe even college. That's why it's graduated. No? Okay. So a graduated cylinder measures volume, and we will get plenty of practice with those momentarily in class as we measure volume.